Welcome to the Wing Helper 1.4 video tutorial. In this tutorial, we present the Wing Helper functionality as implemented in the current version. We would also like to point out that there is a written documentation available for download in which we describe some of the functions in more detail. Okay, so let's start. As you can see, we have already loaded our example wing. All wings in Wing Helper are designed as sets of wing panels. This example wing consists of 3 panels, panel 1, 2 and 3. In this area here, you see a wing. You can rotate, pan and zoom the wing the same way as you know it from other CAD programs. There are also a few view presets available here for you to select from. These presets are particularly useful in the panel editing window, which we will be showing in a few minutes. And in this area here, you have some visualization options which allow you to temporarily disable or enable some of the elements of the wing. Good, now let's see how you can use Wing Helper to design your own wings. For that, we go here on this button called New, press it. We say no, we don't want to save the changes. And again, we have an empty screen. Now this table containing the panels is empty, so let's add the first panel. Press here on this Add button, and what you see now is the so-called panel editing dialog. On this side of the dialog, you see the live 3D view. This view is changed if you change any of the parameters here on this side. You have additional visualization options here, and also you have the same view presets as you know them from the main window. On this side, this is where you enter your data. So let's start by giving this panel a new name. Panel 1. Then we can change the panel code either by entering the number or by moving the mouse wheel or by pressing these arrows here. You can change the tip chord. You can change the sweep, the root twist, and the tip twist of the panel can be specified separately. The dihedral angle is visualized if you choose to do so here by ticking this option, dihedral. By ticking it, the effects of the changes of this value are reflected at once. Good, let's put this back to 0. This option here for the straight trailing edge, what does this do? If you have a very strong tip twist, or a very high difference, very large difference between the root twist and the tip twist, you will end up with, let me put this in a position where we can see it. Yeah, I think it's good here. You will get a trailing edge which is not a straight line. It's like a curved trailing edge. If you want to have a straight trailing edge instead, tick this option, and the interpolation of the twist angle will be changed in such a way as to ensure that the trailing edge is a straight line. The root trip airfoil, the default value is the Clark Y. You can change it, of course. The default airfoil for the tip rib is the same as the root trip. If you want to have a different airfoil at the tip rib, just select the tip rib here and select the different airfoil. So let's find two airfoils which are very much different. Clark Y for the root and CH10 for the tip rib. So we see here at the root rib, this is the Clark Y. At the tip rib, we have the CH10 airfoil, and all the airfoils in between are interpolated. If you want to have the airfoil on the tip rib, again, the same as on the root rib, you press this button to remove the selection for the tip rib, and we have the same airfoil again. Now let's view this panel from the front. The extra settings here, or per default, the ribs are not aligned in any special way. You can give them the top alignment. You can give them the bottom alignment. So, with the top alignment, the line connecting the highest points of the ribs is a horizontal one. Bottom alignment, the bottom line connecting the lowest points of the ribs is a horizontal line. And without alignment, there is, these lines are just determined by the difference in the height of the root rib and in the height of the tip rib. This here is the airfoil table. We have 1,500 airfoils included in the default wing helper distribution. We already saw you can filter the airfoils in this table. Just select the ones you want to see. Yeah. We deliberately skipped over this parameter because this parameter is the only parameter which can be changed here without having immediate effect on the panel. If you want to confirm that the length needs to be changed, you have to go here to the Ribs tab and press the Generate Ribs button. This actually also holds for this parameter here for the rib thickness and number of ribs. If you change any of these three parameters, this one, or this one, you need to press the Generate Ribs button in order to confirm that you really want to generate a new set of ribs. Why is it like this? Because here in this rib table, as we will see very soon, you can also make some manual modifications to the ribs. Changing one of these parameters would cause the rib set to be generated again. So this means that all your manual modifications would be thrown away. Last but not least, here in this area, for the standard airfoils, we have some airfoil data. This data is not available, of course, for the airfoils that you define by yourself or for the airfoils which you import, which you find on the internet and import. This is just available for the airfoils which are included in the standard distribution. Let's move to the next tab, Ribs. We have already seen these two parameters, the rib thickness and the number of ribs. You set these two parameters, you set the desired panel length, you press the Generate Ribs, and your set of ribs is created. Well, you can calculate all these parameters manually and enter them one by one. It is usually easier to press on this icon here. This is our panel length calculator. You specify the desired rib thickness, the number of ribs, and the distance between the ribs, let's say 45 mm. Press OK. The length is changed. these two values are changed, you press on Generate Ribs again, and a new set of ribs is generated. What else do we have here? We have the rib table. Selecting an entry in this table marks the corresponding rib in the red color and shows the rib in this 2D rib view area. The two-dimensional rib view is currently not showing anything exciting, but it will become much more interesting later on when we have defined a few spars, the leading edge, trailing edge sheetings, and stuff like that. Here in this area, you can define your building tabs. You can have them in front or at the rear of every rib. You can have them above, below. You can specify their position from the leading edge, from the trailing edge, the width, the height. And if you also want to have the cutout holes in the building tabs, you can define how they should look like by changing these two values here. As you see, the building tabs are not shown here in the 3D visualization area. The reason for that is that they would usually only be a distraction here. They would protrude through the sheetings. They would be of not much use. Therefore, you only get them shown here in the 2D rib view area. You will, of course, also get them in the DXF output, but as I said, not here. There is one more thing that you can do in the rib table. You can, for every rib in the table, specify the rib's position. Let's say 95 or 105 millimeter. You can change the thickness of the rib. Let's say to 5 millimeter. You can right-click on the rib, add an additional rib before this rib or after the rib. You can delete the rib. You can select the rib and split it in two. So now you have here, instead of just one rib of 5 millimeters, you have two ribs adjacent to each other, each of them 2.5 millimeter thick. And you can also change a visibility of the rib. Let's say we want to take a good look at the root rib from this side. This rib obviously is obstructing our view, so let's say put it invisible. Now it's only outlined and you have an unobstructed view to the root rib. If you want to have a more specific distribution of ribs, you can say here, change rib distribution. From the first rib until the selected rib, I want my ribs to be in 20 millimeter distance from each other. Press OK. You see 0, 20, 40, 60. This is a 20 millimeter distance, and from 60 on, it moves forward in 45 millimeter steps as we had it previously. Let's put it back. It was 45. You surely noticed that changing the distance between the first 4, in this case, ribs, also changed the length of the panel. If you want to keep the length of the panel constant, you need to tick this option here, keep panel length, press OK, and now here we have 20 millimeter distances, and from here on the distances have increased so that the total length of the panel remains as you defined it here. That's all about ribs. If we now press the OK button, we see in the table view that the panel 1 is in the table now. The panel is shown also here as the wing, as the left and the right side of the wing. You can leave a small gap between the wing sides so that you can better recognize where one half ends and the other one starts. Yeah, and that's it. Double click on this line again, and you're back into the edit mode. Let's check the spars. The definition of spars is also table-based, just like the definition of the panels. You right-click into this empty table and say Add Spar in front. Now first spar is here. Let's say the tip chord is a bit longer. Okay, so this is better now. Let's change the spar name. First spar. It's of the type round, and it's going from the first rib to the 10th rib, to the last rib. You can change these parameters just as well. Here below, you also have the parameters which are defining this spar. You can specify the position of the spar. This is the distance from the leading edge or from the trailing edge. Default is 25%. You can specify the distance in percentage or in millimeter. Changing this number moves the spar either from the leading edge or from the trailing edge. You can also say, I want my spar to have a separate end position. Sorry. This can happen if you're using your mouse wheel too fast. Okay, so we have a separate end position. The beginning is at the 17% of the rib, the end is at the 63%. The angle, which is defined by these two different positions, this is this angle here, is 55 degree. You can press this button if you want it at 90 degree. Or you can just say, yeah, I don't need a separate end. I want the distance from the leading edge to be the same at the beginning and at the end of the spar. What else do we see here? We can specify the radius of the spar, and we can also specify the offset in the Y direction separately for the beginning and for the end of the spar. This can be better seen from this side. This will be useful later on when we try to define the leading edge using the round spar. So that's all there is to say about the round spar. Let's add another spar. So right click on the existing one and say either in front or behind of that spar, I want a new one. So the new spar is again from the type round. This is a default setting. You can change it by double clicking here. You see you have the pop-up window with different spar types. The next one will be the rectangle spar. Which parameters do we have for the rectangle spar? The ones that we already know. And in addition to that, we have the width at the start. We can also specify a separate end width if we wish to do so, the height of the spar at the beginning, and if needed also at the end. We can specify a gap in the rib in front and after the spar. What is this useful for? Well, if you have a strongly angled spar, let's say from the first to the fourth rib, separate end position and move the spar like this. Now seen from above, you see that you get a problem here. This problem you can either solve by manually removing or brushing away this part of the rib after you cut the rib, or you can also say, yeah, just make it a little bit wider, and it will be possible to place this spar without any tensions in the wing. It's important that at the end of the spar you will have the same problem, but of course in another direction on the other side. Therefore you will also want to have a gap here. Yeah, that's it. So basically you just widen this cutout for the rectangular spar so that you can place your spar without any tensions. We can also add webbing to this rectangular spar. You can put it in the middle. Let's take away the ribs. Okay, so we can see better. In front, behind, or we can make a box webbing. We can also specify whether the webbing shall be inside or outside of the spars. If you only want to have a partial webbing, a part of the spar with an associated webbing, you say from rib 2, let's say to rib 6, only a part of this bar will receive a webbing. If you want it to extend all the way until the last rib of this bar, you either enter the number of the last rib, or easier, just type in 0. And the 0 is a special value saying all the way until the last rib. Last but not least, we also have the possibility to only have the spar on one side, or in a most extreme case, to have no spar at all. This does not make much sense, so let's just put it on both sides. Webbing. You can also have the webbing standing on its own. It does not have much parameters, just the width. You can have a round joiner. So let's remove these bars. So what is a round joiner? It is very similar to a round spar, with one important difference. You can only specify the beginning of the spar, the starting position. And the end position is automatically set so that this bar is always at 90 degrees angle. You can change the radius. You can change the offset. The most important virtue of this bar is, of course, when it comes to the dihedral angle. If you define an angle, this bar still remains horizontal. Let's see it in the main window. We have a nice horizontal connection between the two wing halves. The next one is a cuboid. It's not much different than a round spar. It only has a few additional parameters, of course. You can specify the width and the height, and you can also specify a rotation. The next one is a cuboid joiner. Cuboid joiner is also very similar to the round joiner. It's always horizontal, and it's always at 90 degrees. Here. And last but not least, an important addition to the Wing Helper 1.4. This is a special kind of spar. This is an aileron cutter spar. You can define your own ailerons. What do we have here? The positioning. We know that. We can say whether the hinge should be above on the upper side of the rib, whether it should be below, whether it should be cut off, or whether we just want to know where these cut-ins in the rib shall be placed. This option allows us to build the rib in one piece, including the aileron, and after the wing is finished, you can just cut off the aileron along these lines. Okay. The width parameter specifies the width of this hinge point. The cut parameter specifies how far in the rib the closing walls shall be placed. Alpha is this angle, beta is this angle. We can say whether we want to close the walls at all or not, and also how thick this material here should be. If we now turn off the ribs, we see how this will look like. If we turn off the spars, we see how the rib are going to look like. If you say don't cut off, this is what you'll get. So you will have the right places in the rib to insert the closing walls. That was all about spars. Let's move to the leading edge. The simplest way to define the leading edge is just to say I want my standard leading edge. You can only change one parameter here, the depth. If you don't want to have the standard leading edge, but a round strip or a diamond leading edge instead, you see here, this is currently not possible to do in an automated manner, but we can help ourselves with a correctly positioned round spar. Let's define one. So we have a round spar. We put it right at the beginning of the rib. Let's disable the axis. Millimeter, it's better, I suppose. Yeah, and this is where this delta y offset parameter is useful. Okay. At the end, the position, the distance is correct. And in this case, the offset y end is the same for the end as for the start of the spar. The strip and the diamond leading edge are similar. We just don't take the round spar, we take the cuboid, we make it wider and thinner. Okay, a bit in this direction. On the other side, it matches pretty good actually. Yeah, maybe 4.2, 4.4, yeah. Finally, if you want a diamond leading edge, then the width and the height will be the same. You will probably want a rotation of 45 degrees. And the parameters now are already set correctly because we already did so in the previous step. In this case, there is no need to adjust them. Yeah, this looks about right. On the trailing edge side, we also have the standard trailing edge, where we can specify the depth of the edge. There is this automatic adjust parameter, which makes the depth of the trailing edge different for the first and for the last strip. If you tick this field, automatic adjust, then the percentage of the last strip, which is cut off by the trailing edge, will be the same as the percentage which is cut off on the root strip. So the difference between the length of the last strip and of the first strip in the panel, specify in percent the difference of the depth of the trailing edge here at the first strip and here at the last strip. If you don't want to have the standard trailing edge, you can also simulate this by cleverly placed spars or sheetings. Let's say no trailing edge, go to spars, change this one to a rectangle spar. Say we only want the bottom side. We give it a bit more width and we move it all the way back until it's placed correctly. Here we will want to do it for the front side and for the back side of the panel separately. So it's 8.7. Yeah, this is good. And on this side, well, on this side actually it already looks quite good. Yeah, so this is how you can specify a different kind of a trailing edge by means of a rectangle spar with only the bottom part activated. The next tab on our list is the sheeting definition tab. We click here and we see there are two ways to define a sheeting. The first one is not supported anymore. It is still here only for compatibility reasons. We strongly advise against using this kind of sheeting. Just for the sake of completeness, let's take a look at what it does, or better, what it did. It was possible to specify the length of the sheeting, the thickness of the sheeting, and the number of ribs starting with the panel root rib and ending on a given rib. In this case, it's the rib number 2 or the rib number 3, until which the sheeting will extend all the way to the trailing edge. As I said already, we are not using this sheeting anymore. In future versions of Wing Helper, we will remove this option, so please just move to the advanced sheeting, which is here. The advanced sheeting consists of a list of sheeting strips, also defined in a table, just like the spars. Click on the right mouse button and say Add Strip in front. And we already have our first sheeting strip. Now what do we have here? Strip number 1, the starting rib, the last rib. You can specify them any way you like. You can also specify whether the sheeting strip starts at the leading edge or at the trailing edge. You can move the position where the sheeting strip starts. You can also specify a separate position, separate starting position at the end of the sheeting strip. There is the length of the strip. You can have the length of the strip at the end, a different one. Thickness, apply above or apply below for partial sheetings. And you can also say that this is not a full sheeting, this is just a capped strip. In the end effect, in the DXF output file, there will be no difference considering the ribs. But for the visual effect here in the 3D area, we have this option. Let us try to replicate by means of the advanced sheeting what we saw here previously. So obviously we need 2 strips. One starting at the beginning of the rib, 25%, and the other one starting where the first one ended. Right click, add strip behind, strip number 2. Let's say it starts at 25. This is where the previous sheeting strip ended. It only reaches out to the 3rd rib and it extends all the way to the trailing edge. That's it. There is one very important thing which I would like to stress out here. Let me define a rectangular spar also. Good. It is very important that you never have elements influencing the outer side of the rib. So in this case, this will be this side, and on the bottom, this one. Never have elements influencing the outer side of the rib overlap with each other. Why? Let's try to overlap them. And you see, the program has no means to know what you actually wanted to say with this setup. And the result is for sure not what you expected. Now, if we would move the rectangle spar to here, now it's overlapping with this sheeting strip. The things get even worse. Let's remove the spars and the sheetings, and we see this is a result that we for sure did not want to have. To leave a very small gap between the elements is much better than to allow them to overlap. Because if you leave a very small gap between the elements, let's remove the sheeting, you see that the wing helper will recognize this minuscule gap as just as an artifact which should be removed, and it gets automatically removed. On the other hand, if you have a very small overlap, you will get a dent in the rib, and this is for sure not what you want to have. Now in this case it is pretty simple to solve the situation. Just put 25 here and we are good. In more complex cases, if you have a few spars being next to each other, a few sheeting parts, maybe also involving separate end positions and differing airfoils, it is very useful to have the 2D rib view and the table in front of you. So let's rearrange things a little bit. Okay. Now, as we said previously, the 2D rib view will become more interesting when we get to the spars and to the sheetings. This is the time when you have your wing panel defined. Please go into this position, go into this setup, and take a good look at every single rib in order to make sure that there are no overlaps and no strange things. For example, here we see that we would have an overlap with the building tabs. So let's go and change the position of the building tab. Yeah, now we are good. This window can also be resized. You can also move it to second monitor if you have one. This is a very useful thing and we really recommend you to make use of it. These windows are also active if you are in another view, like for example the spars view. Let's change something on the spar. It is also moving in the 2D rib view. Put these teared off parts back in just by pressing here on the symbol, and they are on their original locations. The last thing that we have here is this construction tab. Here we find the rib comps and the lightening holes. The rib comp, let's add one. I think this is good like this. Here we can say the rib comp is a sort of a webbing which can be inserted into the rib. So the rib receives a notch here, and the rib comp has a corresponding notch also. So you just get more or less a webbing which can be just inserted into the ribs and which also can be used as a replacement for the building tabs, because the length of the comp extends per default as far as the tabs would extend. You can also say, I want to specify on my own the extension, or you can say, yes, let it extend as far as the building tabs would go, and in addition to that, also add some length more. Now what I just noticed, you see this dent here. This means that we have an overlap here. Yes, and the overlap is here with respect to the sheeting. Just take away the transparency. You will see that the rib comp and the sheetings are overlapping here. So my suggestion for this case would be to have this rib split in two, to have this comp only go to the rib on the left, and remove the rest of the comp here. How do we do that? We select the rib, split the rib in two. Now we see that the sheeting goes until the rib number 2, and the comp goes until the rib number 3. And the rest of the comp should be removed. I think 3 was correct. Oh, 4, okay. Because 1, 2, 3, the 4th rib. Good, what else do we have here? We can specify the width of the comp. We have already seen this value here. We can specify how far into the rib the comp will protrude. Now this is a good situation where we can make this rib invisible. Okay, so we see here that this comp is cutting into the rib 50%. You can reduce it. You can not make it more than 50%. 50% of the rib is the maximum height. The gap 4 and the gap aft are the same as what we had with our rectangular spar. The needle adjustment, the slit height, the height of this cut-off slit, and you can also actually influence the width of the slit. Last but not least, the lightening holes. You can have them as standard holes, which are just, let's say, rectangular. If you want them to be smooth here in the edges, you click on the round corners, or they can form a series of triangles with these additional supports here. Supports are drawn whenever there is enough room for them. For example, here you can't put the support because there is not enough room here on this side, and therefore here we have the same lightening hole as what we would have if we chose the standard holes. The parameters are, I think, relatively easy to understand. Just play with them until you find the setting which suits your needs. That's all. If we now press on the OK button, we see that this already starts to look like a wing. Okay, we have the first panel defined. Now let's proceed and define the next one. Press the Add button, and now the program is asking you whether you want to just create a new panel without copying any of the settings from the previous one, or whether you want to take over the settings of the panel number 1 and apply them to the panel number 2. Let's say we don't want to copy anything, and the new panel looks just as the old one, just as the first one looked, just the ribs with some basic similarity to the previous one. If we take a look from above, we see that the previous panel, which is here shown rather transparent, we can also change the transparency of these ghosts panels. The ghost panels are the panels to the left and to the right of the panel we are currently working on. We see that the sweep is the same the trailing edge extends without a nick, and that the airfoil of the first rib of the new panel is the same as the airfoil of the last rib of the previous panel. Other than that, nothing is copied. Now you can proceed and add the trailing edge, the leading edge, and all the spars you need manually, or we can just throw away this panel, say add again, and press yes, please copy the settings from the previous panel. There are 3 different ways to make a panel copy. They are explained rather in detail in the PDF manual. Let's for now just keep the smart copy option. Press OK. And as we see, everything from the previous panel is now copied into the new one. So we have, if we take a look at the spars, we have the rectangle 1 spar here, we have the rectangle 2 spar, which is mirrored. These two are mirrored around the connecting rib because they are protruding all the way to the rib. Everything which touches the rib gets mirrored, and everything which does not touch the rib is just copied as it was. So in this case, this is this joiner, this aileron are just copied, and this joiner and these 2 spars are mirrored around this rib here. The dihedral angle is also copied from the previous panel, so we will have the same dihedral angle between the wing halves and between the 2 panels. If we want to reduce it a bit, we can, let's say, put this to 8. Okay, good. Now let's see what we need to do manually now. Obviously, we don't need this spar, so we can remove it. This bar here is mirrored a kind of way. If a spar has a separate end position, then the mirroring is just partial mirroring. The starting position is correct, but the angle is not copied. So we can either now change the angle, or we can use the function align with previous, in this case with the rectangle 2, and the spars are aligned. Let's take out the dihedral so that we can see better. The spars are aligned just like these 2 and these 2. Dihedral back on. What else? We see that here this is actually correct position for our joiner, but it is a little bit too low. Let's move it a bit higher. Okay. And please don't forget, if you move this one, you also have to adjust the previous one. So let's say OK. Go back into panel 1. Now the second panel is the ghost panel. We go here to the cuboid joiner, right click, align with next, with the joiner number 2. The names are the same. And the delta Y setting is copied. Let's remove the leading edge. Okay, the ribs maybe also. Good. Now you can see that these 2 spars are perfectly aligned. They form one straight spar protruding from the panel 1 into the panel number 2. Now that we have 2 panels, we can also check out another function which is new in Wing Helper 1.4, and this is this airfoil spanning function. Previously we saw if we have a different airfoil selected for the last rib, all the ribs between the first rib of the panel and the last rib of that panel are going to be interpolated. Now, if you want this interpolation not to only reach within one panel, but to actually span multiple panels, you go here, press Airfoil Spanning. Now we have only 2 panels defined here, the panel 1 and the new panel. Let's say the connecting rib between these two should also be interpolated between the root of the first panel and the tip of the last one. We press OK. And we see that the connecting rib is now marked with the red color. There is also this red symbol here showing that at this point we have the airfoil interpolation activated. Let's take out the dihedral. Oh, okay, I didn't want to do that. Good, now let's say we remove the spanning. Good, and now we can see with undo and redo how the wing changes due to the airfoil spanning parameter. For the demonstration of the next function, we loaded our sample wing again. As we can see here, the wing now consists of only panels with straight leading edges. If you want to have a nice, smooth, curved leading edge, or trailing edge for that matter, you go into this Planform area, and here you can say modify rib. You can extend every rib to the position defining some sort of a curve. If we see here what we did, this does not make much sense, but I think it's a valid demonstration of the function. So let's do something better. Let's try to really define a nice curved leading edge. We can try to do it by hand, of course, just as I showed you here. It is much easier, however, if you have the image of the Planform. You can fetch it from the internet, you can draw it by hand, you can prepare it in a drawing program. Then you can load it here. Load Planform image. Now we need to move it to the correct position. We start out by setting the background image anchor as a point, which will be the point of reference for all further operations like moving and scaling. Double click to get out. Move background image. I will zoom in again. Move it here. This is where we want to work very precisely. And then we say scale. Click somewhere here and just pull your mouse until the last rib, click again, and the background image is set. Now this image corresponds perfectly to our panels. This is of course not by accident. We prepared it to be like that. You will probably need some fine-tuning here, considering the sweep of the panels. Move on to actually modifying the ribs. You don't have to start the function modify rib over and over again. Once you start the function, it will remain active until you start another function or until you press the escape key. This one is almost perfect. Good. Back to the plane definition view. From above we see we now have a nice curved leading edge. You probably noticed that I did not move these points. Let's say modify rib, tried to move them. This is not possible. The first rib and the last rib of a panel cannot be modified in this view. The first rib of a panel and the last rib of a panel can only be modified by means of this panel edit dialog. Let's say we increase the sweep a little bit. And now we have here this 5 mm gap, because we just changed the sweep parameter. Undo, get back. What is the reason? The reason is if you would be able to change these ribs here in this view, this would be actually changing the base parameters of the panel, which would be rather confusing and actually also error prone. For that reason, we decided not to allow changing these ribs here. If you want to change them, as I said, just go here and change them here. The next big improvement in the version 1.4 considers Airfoil Management. Let's go to File, Manage Airfoils. And you get to see the new Airfoil Designer window. In this area, you see the selected airfoil. This is the list of all airfoils imported by you or manually created by you. You can delete an airfoil from the list. And there is also this filter function that we know from the airfoil list in the panel edit dialog. What do we have here? We can import a new airfoil. We can set a background image and remove a background image, just as we saw in our Planform editing area. There is an undo and a redo functionality, and once the airfoil is done, we can also save it. Oh, I almost forgot. Of course, you can also create airfoils of your own by clicking here on this new button. Let's start by importing a new airfoil. Press import and select an airfoil. Let's say, okay, so I already have this one. Let's delete it. Good. Now we can import it again. We press on a .dat file. Here we get the chance to automatically smooth out the nose portion of the airfoil. For example, if the points to interpolate is set to 2 and the length in percentage to 25%, then the 25% of the airfoil we are importing is going to be smoothed out by inserting 2 interpolation points, 2 additional points between every 2 points which we found in the input data. Let's say yes, we want to smooth out the nose portion. Press OK. Airfoil name is read from the file. Press OK. And we have this new airfoil imported. If we now go here, try to find this imported airfoil, we can see it's here. This symbol means this is one of the imported or manually created airfoils. Now, of course, our spars are not fitting anymore, but this is not important right now. Let's press cancel and go back into the Airfoil Management window. And let's say we want to define an airfoil of our own. Press New. Here you see there is a template so that you have a starting point. Let's set the background picture. We have prepared this one. Let's position it and scale it as we know from the Planform editor. Set background image anchor here at the nose. Double click to get out of the zoom. Move background image. Okay. And let's scale it. Click again. And that's it. Now comes the tedious work, moving all the control points to the correct positions. Now we see that here we need a few more control points. Let's say add control point. Add a few of them. Yeah, and then just, as we already saw, take every single one of them and move them to their correct positions. Press Save. It was Selig 1, 2, 2, 3. And if we now again go here, look for this one. It's there. We have just created a new airfoil. Now, when creating own airfoils, you will probably want to have a pretty high resolution background image. In this case, if we just look very closely, we will see that there are irregularities, that the airfoil is not really very nicely fit, but the more precise the background image that you have, the better the job you will be able to do. Once the wing is finished, you can export it into one of the supported formats. What do we have here? We can export it as a PDF or DXF, SCAD or ICE. Let's start by PDF. Click here. You can either send it directly to the printer, which I personally don't really like. I prefer to print it into a file, export it into a PDF file. Then I can open this file with an Acrobat reader or whichever PDF viewer you are using, select the pages that I want to print, check whether everything is correct, and then send the file to the printer. Let's say we take the A1 and press here on the print preview. What we see here are the ribs belonging to the panel number 1, the ribs belonging to the panel number 2, and the ribs belonging to the panel number 3. Here on this side, there is a table considering all the dihedral angles in the wing, including the information how to set up your build environment so that you can actually join the wings in exact these angles. And this here is also actually very important. I usually print this page first and then measure on the paper whether this line here is actually 10 centimeter long. If it is not, then this usually means that something is wrong with the printer setup. Most probably the margins are not set to 0 millimeter. So my recommendation would be print into the PDF file, then print this side. If the printer puts out this line as 10 centimeter or 4 inch on this side, of course, then you are ready for printing. We move further below. This is the plan view of the first panel, the plan view of the second panel and of the third panel, and of course also for the other wing half. Let's go back to the ribs. The PDF output is actually only very basic output. It contains the nose checking template, the rib itself, but not much more. You also don't see the building tabs here. Instead of them, you see these helper lines. You can cut your rib along the rib line, then decide, for example, that you want a building tab here. You cut all the way down to this dashed line. This is important to get the correct height of the building tabs. Back up and continue cutting. The building tabs are exported into DXF, but here you get these helper lines in 1 centimeter distance. And if we take a look now on our plan view, you will also find the corresponding helper lines in the 1 centimeter distance where you are supposed to put the rib. These lines match the lines which we saw at the ribs. So let's proceed to the next one, export to DXF. You have a few options here. Press the OK button. Yeah, it complains that it's already there. Yeah, just overwrite it. And we have already loaded it here into LibreCAD. Here we see all the panels, panel 1, 2, and 3. Please be aware that dihedral angles are not considered in this view. So every panel is just laying flat on the table. They are supposed to be built separately and then joined in the correct angle. So this is the plan view. Then now here we have our ribs, also with the building tabs as defined. The nose checking templates. And further below, also the rib comps. So, sorry, these are the rib comps. And the aileron sides, the spars, and everything else. All the way down at the end, you will find a few useful tips and tricks. If you have any additional tips and tricks you would like to share with us and with other Wing Helper user, please feel free to send it to us and we will be happy to include them in the next version. The next export target is a SCAD. This is a 3D format which can be opened by a free open source program called OpenSCAD. If we press on that menu entry, we will see the options, the parts of the ring which we can export. There is a link to the OpenSCAD project page. Just press the OK. And this is how the final result looks like. I just noticed I forgot to export the sheetings. Let's also export the sheetings. From here, you can press the render button. This takes quite some time. And after the wing is rendered or prepared for further export, you can also export it into STL format, which in turn can be loaded by practically every 3D modeler program out there, like, for example, the Blender. Finally, there is also the possibility to export the wing in a G-code format. The currently supported one is the HOW corresponding to the program ICE. You press on this menu item and you will get a few parameters. You can set a link to the ICE documentation. This is an external link, unfortunately at the time being German only. In the next version of Wing Helper, we will be moving also towards supporting the NC format, which is a more widely spread one. If you speak German, just go to that web page and get all the additional information, respectively the program ICE. Let's just take one short glimpse at the corresponding web pages. The OpenSCAD web page is here, www.openscad.org. This is a very interesting, very innovative approach to 3D modeling. You basically describe your 3D objects by using plain text, and the program transforms this description into a 3D model. This is the web page of the ICE program. As I said, at the time being, unfortunately only in German. You can download the software from here, and there is also a very good video tutorial about how to use the program to be found behind this link here. Okay, we are at the end of our video tutorial. If you have any questions or suggestions for extensions or for additional functionality which you would like to see implemented in the Wing Helper, please don't hesitate. Contact us using our email address, our forum, or via the Facebook page. Just let us know how you are doing. Let us know what you would like to see. And if you would like to share your designs with us, we will be very happy to put them on our Facebook page or in our forum.